I'm going to talk about machine learning in Earth system science, geography, related fields, and what is unique. What are the challenges, unique challenges in applying machine learning models to geospatial problems? So I approach this with a geostatistical background and with an eye also on several applications that were mentioned in the introduction, things like natural hazards. As examples, I'll be using a remote sensing case study and mapping of pollutants in the environment. Those are important fields, and we've seen at this conference also examples of the application of machine learning and deep learning in remote sensing in particular. So those are applications where we are seeking to obtain the best possible predictive performance in applying machine learning models. We hope to get that extra percentage of overall accuracy in mapping land cover, land use from remote sensing imagery, or mapping hazards, landslide hazards, for example, is one application that I work in, or using point measurements of air or water, groundwater pollutants to obtain an optimal map of the distribution of those pollutants to help direct the site mitigation efforts, or as in one of my case studies, the designation of nitrate polluted areas, which will then result in restrictions for agricultural fertilizer use. Yeah, so those are examples where predictive performance of machine learning offers and perhaps promises to help us make better decisions in science, but also in the world out there in decision making. And however, at the same time, we're often interested, and especially in science, in model interpretation. We want to learn from the data. We want to learn about the world around us from data, which is the basic principle of evidence-based decision making. Even in a predictive setting where we want to get the best prediction map, we still have to justify our actions. We have to justify why people are not allowed to build in an area that is deemed to be hazardous for landslides, and therefore our models must be explainable, must be trustworthy, fair, unbiased. And the decisions that we make based on machine learning, based on artificial intelligence, they must be reproducible and explainable. And therefore, what